Every mammal sleeps, and there are a lot of theories, but there's no real proof of why we sleep because it's hard to eliminate sleep and test the result.
That's Dr. William C. Dement, one of the fathers of sleep medicine. If he isn't sure why we sleep, we can at least try to understand what happens when we close our eyes at night.
I'm at a sleep clinic about to get a sleep study done, and it's going to be a 2-hour test. It's not going to be the typical 8-hour test. So let's see what my brain says about my sleep. I guess I really am sleeping on the job.
Sleep was once considered an inactive state in which our body and brain simply shut down to rest. Scientists have since found our brains are actually highly active during sleep, and our brain repeatedly cycles from one stage to another. Within the first 90 minutes of falling asleep, we enter REM, which stands for Rapid Eye Movement. This cycle was only discovered in 1953.
I would go in with a flashlight, and there was a person would be sleeping, and lo and behold, I would see the rapid eye movements. They're actually very easy to see if you're sitting next to the sleeper.
Throughout this cycle, our brain is almost as active as it is when we're awake.
Something very unusual happens. So the heart beat will be irregular, breathing will be irregular, and changes in brain temperature control in the brain occur.
It's also the stage when we're likely having very vivid dreams, which is why our body is essentially paralyzed. This lack of muscle activity is known as atonia, and is believed to be a protective mechanism to prevent us from acting out our dreams and getting injured. In non-REM, the body is in a much quieter state. The brainwaves become slower and the eyes remain still. It's divided into 3 stages, N1, N2, and the deepest stage of sleep, N3.
It's very hard to wake up out of N3. If you took a 30-minute nap and somebody wakes you up, sometimes you feel lousy. And that's because your brain is in a different chemical state.
N3 is also when the supply of blood to the muscles increases and the body repairs and grows tissue, which brings us to why sleep is so important.
Sleep allows the brain to reorganize. The wiring of the brain adapts in the night. There's also a role for sleep to clear out metabolic waste. Junk, misfolded proteins get washed out,
including proteins that can lead to Alzheimer's disease and dementia. It's known as the glymphatic system. Think of it as a self-cleaning system that flushes away all the neural garbage clogging up our brain. While we're asleep, cells in the brain shrink by 60%, creating more space between the cells and allowing cerebral spinal fluid to pump more easily through the brain tissue. Generally, adults need 7 to 9 hours of sleep, typically done in one shot. But it hasn't always been this way. Evidence shows that for centuries, our ancestors had a first sleep and a second sleep. They would often wake up in the middle of the night to read, pray, or engage in other activities, and then go back to bed again. This all changed after the Industrial Revolution, and thanks to Thomas Edison, the spread of electricity ignited a change in routine.
Cultural attitudes shifted, unleashed by the Industrial Revolution, privileging efficiency, profit. People became increasingly time sensitive.
Today, 1/3 of Canadians are not getting enough sleep. Over 25% of the population suffer from sleep disorders, and if you set an alarm clock, chances are you're sleep deprived.
Setting an alarm clock is sending a signal to the brain to get up before it would naturally tend to do so.
Insufficient sleep is associated with health issues like obesity, cardiovascular disease, injuries, depression, and reduced well-being. On the other hand, oversleeping isn't much better. The world's largest sleep study held at a Canadian university recently found that if you sleep too long, it's almost as bad as not getting enough sleep. All this is dictated by our circadian rhythms, a biological clock that does not have a snooze button. It keeps our body in sync with the cycles of day and night and is synchronized to the rising and setting of the sun. In the morning, light sends a signal through the eye into the brain's hypothalamus to the master clock, called the suprachiasmatic nucleus, or the SCN. The SCN then tells the rest of the body to raise body temperature, heart rate, and blood pressure. Our alertness and concentration sharpens, and our body is ready for a new day. When there's less light, like at night, the SCN tells the brain to make the sleep hormone melatonin. So you get drowsy, the organs start to slow down, bowel movements are suppressed, and the body temperature cools. For most adults, the biggest wave of fatigue comes in the middle of the night between 2 a.m. and 4 a.m. The second lull comes just after lunch around 1 p.m. and 3 p.m., which is why you shouldn't necessarily feel guilty about craving an afternoon nap.
But there are many ways to confuse the master clock, like exposing yourself to digital light while binging on your favorite YouTube videos before bed.
Or working odd hours and traveling across time zones. So what is the best way to fall asleep and stay asleep?
Letting worries and thoughts go. Counting sheep, just kind of a meditative kind of process.
And while there is no blanketed solution to get a perfect night's rest, one thing is for sure, there's no way to get around the need for sleep.